Delta 1398 is declaring an emergency. We've got plenty of fuel, and onboard souls are by. Souls on board 92. Probably up returning to Boston. We have a fume event, kind of like smoke in the cabin.
1398, right? You said the Boston Airport via spare vectors, turn left heading of a 130, 130 heading. Descend and maintain probable 240.
Left turn heading 130, 240, descend, Delta 13. We'll be right back.
Hello, this is your instructor speaking. Today we will going to start a new series on the Boeing 737 NG system. In this first video we'll explore the ATA-24 system, which is the electrical power system. This will be a 3 videos series on the ATA-24 system. So before we begin, let's delve more on what is ATA. The ATA stands for Air Transport Association, and it's a standardized system used to categorize aircraft system. The ATA-24 especially covers electrical power, everything from power generation to distribution and control. It's mainly the electrical power system, power everything from the cockpit instrument to the cabin lights and even the engines, and of course ignition systems. So in order to know the importance of the electrical system, imagine flying at night without cockpit lighting or losing power to the flight instrument. It's not just inconvenient, it's very dangerous. That's why the ATA-24 system is designed with redundancy and reliability in mind. Let's break down the main component of the ATA-24 system. The electrical power system makes and supply AC and DC power to the airplane. The system has automatic and manual controls and protection. A standby AC and DC system gives normal and emergency power. The electrical power system uses automatic control to protect the system from source failure or load failure. Of course, for manual control of the electrical power system, we have 3 main panels found in the overhead panel. Of course, number 1, electrical meter, battery and galley power module, which in P5-13, generator drive and standby power module, which is in P5-5, and the last one, AC system, generators and APU module P5-4. These are the 3 main panels for manual control, of course. This is another view for the 3 panels above each other. The electrical system has 4 main AC power sources and 1 standby power source. These are the main AC power sources and their supply capacity. We have the left integrated drive generator, which is coupled in with the engine number 1. The IDG1 supply 90 kilovolt ampere, and we have of course right integrated drive generator or IDG2, which is coupled with the engine number 2. The IDG2 supply 90 kilovolt ampere, and we have APU starter generator, which is supply 90 kilovolt ampere below 30 to 1000 feet. and goes down to 66 kilovolt ampere at 41,000 feet. And of course, the last one, we have ground power unit for ground maintenance, which is supply 90 kilovolt ampere. The IDGs and ABU starter generators supply a three-phase 150/200 volts nominal at 400 Hz. The AC power system designed to prevent there are two sources in the same to the same load at the same time. There are no possible that the AC power system designed to prevent two sources to the same load at the same time, which is common to known as paralleling. There are no paralleling in the B737. And the last one, that the static inverter supply a one-phase 150 volt AC output to the AC standby bus. The primary AC electrical source is supplied by two engine-driven integrated drive generator, or IDG. The IDG are lubricated and cooled by a self-contained oil system. The IDE supply power directly to the AC transfer bus. This is the AC transfer bus. Each IDG is controlled by a generator circuit breaker, or GCB. This is the GCB, or generator control breaker, generator circuit breaker, or generator control breaker. The IDG supply power directly to the AC transfer bus. Each IDG is controlled by a generator circuit breaker, or GCB. The transfer bus are connected to two BTBs, or bus type breaker. The transfer buses supply power to the remaining AC buses and the transformer rectifier, or TRU. So the transfer bus number one is go to the TRs, and from AC transfer bus it goes to the remaining AC buses. The electric power system uses automatic control to protect the system from source failure or load failure. This line replaceable units, LRU, supply the system with protection and control logic. We have 4 units, which is control and protect its own sources. Number 1 is left generator control unit, GCU1. Number 2 is right generator control unit, or GCU2. Number 3 is ABU generator control unit, or AGCU. Number 4 is bus power control unit, or BPCU. The bus power control unit is mainly used to protect and control the external power. This is the overall circuit for the B737 6 and 7 and 800. We have 2 IDG, which supply 90 kilovolt, and we have ABU generator, which is supplied 90 kilovolt, and we have, of course, external power for ground use. We have GCU1, GCU2, we have AGCU, and we have, of course, BPCU. So that's it. We have finished the AC system. I hope you are more informative after we cover the AC system. Wait us for the next video.